Hi guys, it's me again and welcome back to my YouTube channel. Today we're gonna be talking about progress. Have you ever encountered such graphs like these in the stock market? The up and down and the progress of the values of the shares? Have you ever encountered data when it comes to the world population presented in graphs like this? Or when you were a baby, you are given such a graph like this to monitor your weight as you grow up. As you can see, these are represented by lines to show progress in a period of time. Such progress like this are represented by graphs of what we called line graphs. My name is Joffit Lazo Vargas, and you may call me Teacher Faith. Our objectives for this video is that at the end of this video you will be able to 1. Identify the parts of a line graph. 2. Determine specifically what are line graphs made for. 3. Know the limitations when creating line graphs and know types of line graphs. And 4. Analyze line graphs. These are the parts of a line graph. On the topmost part is the title. It gives an overall description of what the line graph is all about. Here on the X and the Y axis are the labels. It gives the label of what are the categories under the X axis and gives the description on the scale on the Y axis of what those numbers are all about. This one gives the category, which is mostly and obviously is a timeline, as line graphs show the progress of data over time. And here on the left, we have the scale. A key or legend is presented on any part of the graph. This exists especially when there are two variables being compared to. On that part, we have the dots. Okay, some line graphs do not have dots, and some which specifically shows under what time and how many are there in a certain scale. So how to read a line graph? For example, here this one, this dot, whatever time is being aligned. So this is Thursday, and we have here 14. So here in the title, it gives an overall description of attendance of Emerald class for week 9. That means on Thursday, there are 14 attendance. Since this is blue, male, there are 14 male who are present on Thursday. And that is how you read your line graph. And overall in this circle, that is our data in progress. So these are all the parts of a line graph. So line graphs are maybe compared to bar graphs, but line graphs are only specifically made to show changes in data. Line graph is a tool used to compare data over time. So usually here, we have week. You may use time, seconds. You may use days, hours, weeks, years, or any category as long as it is on the unit of time. What are the limitations of a line graph? So, and because time only goes forward, lines never go backward. So let's say, for example, if we have this bar graphs, and you will try to convert it into a line graph. So if we are going to use this one, as you can see, there is line here that goes backward. No, it cannot be. Also this one, this wave here, can we do that one? Can we create line graphs that go backward? No, it cannot be. only we can use lines that go forward. Lines cannot go backward because time never goes backward. These are types of line graphs. First, we have the line, the simple line that has no markers. Then we have the stack line. Stack line are line graphs that whose values are being summed together. Then we have here 100% stack line, in which the values on the scale are in percent rather than their actual scale like here. Next, we have the lines with markers. It is similar to the simple line, but they have dots that gives a distinction of where or what part of the line has the values of the category or the scale. Next, we have stack line with markers, similar to stack line but has markers. And the same thing with 100 stack line but with markers. So, let's start practicing in analyzing our line graphs. Example number 1. The graph below shows the number of patients who visited an emergency room for the treatment of scooter-related injuries. Here we have the title, West Side Hospital Number of Emergency Room Visits Related to Scooter Injuries. So, our x-axis tells us that the record is by months, May, June, July, August, September, October, November, and the scale here on the left gives us the number of ER visits. Practice question number 1. In which month did the greatest increase in scooter-related injuries occur? So we only have to watch if which among the months here has the greatest increase in the slope. So obviously we have here from July to August, so our answer is August. Question number 2. In which month did the number of scooter-related injuries decrease? So we only have to see the line that goes down. And here we have October. Number 3. To the nearest 10, how many emergency room visits were due to scooter injuries in August, September, and October combined? So we have to determine how many are there in August. So we have 80, on September 110, and on October we have 90. So add them all together. We have approximately the nearest 10, 280. And the last question. Which of the following shows the greater percent of increase? A. The change in injuries from June to July, or B. The change from August to September. So we're going to watch first or to know first the data on June to July. So data in June tells that we have 15 and July that is between 20 and 40, so we have 30. So we're going to solve. 30 minus 15 gives us 15 divided by 15, the original amount or the original number of ER visits. So that it gives us 15 divided by 15, 1. That gives us 100% of increase. While on B, we have August to September, 110. Since we have here 110, then minus 80 gives us 30 divided by 80. Give a 0.375 or moving two decimal places to the right, 37.5%. So that means the greater percent of increase is on letter A, the change in injuries from June to July. Example number 2. The graph below shows the change in ticket prices for 2 amusement parks. So here are the different amusement park tickets illustrated. Now this type of graph, we can use this when we are trying to create a line graph using only one color. So in this case, we can use different patterns of lines. On part A, we use the straight line, while on part B, we use a dotted line. So in this y-axis, we have this ticket price with the interval of $10, while here in the x-axis, we have the time in years. Practice questions. What was the last year in which the admission price to Park B was greater than the admission to Park A? So we have to look for the lines in which the last year that Park B is higher than Park A. So you have 2005, Park B is higher, 2006 still, 2007, but when it comes to 2008, they had switched places. So this is our answer, 2007. Number two, how much more did it cost to buy a ticket to Park A than a ticket to Park B in 2009? So we will only focus here in 2009. So this since uh, we don't have an accurate grid lines, we only have to make an estimation. So this is between 30 and 40, so 35. Between 35 and 40, we had around 38 or 39. Let us say 30, 38. So here on 20 and 30, between is 25, but since this is closer to 30, we can have 29. So we have 38 minus 29 is around $9, but we can have an estimation, so approximately $10 more. Number three, what was the percent of increase in the ticket prices at Park B from 2005 to 2010? So we will focus only on the dotted line, Park B. 2005, Park B's price is, here we have between 30 and 20, so $25, while in 2010, $30. So we will subtract 30 minus 25 divided by 25, the original ticket price. So 30 minus 25 is 5. 5 divided by 25 gives us 0.20, and moving to the small places to the right, we have 20% of increase in the ticket prices. Number 4. To the nearest tens, how much more did it cost to buy a ticket to Park A in 2010 than in 2005? Okay, so we will focus again on this line, Park A. We will have to disregard the dotted line, Park B. So how much more did it cost? So we have get the price of Park A in 2005 and get the price of Park A tickets in 2010. So 2010 minus 2005 prices of Park A. So we have $45 minus 20. Since 45 here is between 40 and 50 minus 20. So this is an approximation. Okay, only an approximation. So we have 25. So it costs $25 more to buy a ticket in Park A in 2010 than in 2005. So, now you try. Example number 3. If a purchase cost $100 in the year 2000, what would have been cost in the past? So this table records inflation over time from year 1920 up to year 2000 in an interval of 10 years. While here, the inflation from $0 to $100 with $10 interval. Question number 1. Over what period of time did the price of goods actually decrease? So you only have to look upon here which year among the options here on A, B, C, and D had decreased. So 1920 to 1930 had decreased, 1930 to 1940 had also decreased, while the rest of the years had increased. But since 1920 to 1930 is not part in the options, so our answer is 1930 to 1940. Letter A. Number 2. Goods purchased in 1970 were about what fraction of their cost in the year 2000? So 1970 we have here at around 20, approximately $20 compared to $100 in the year 2000. So our solution is 20 divided by 10 equals 2 over 10, getting their zeros, or round off to the lowest terms, we have 1/5. So our answer is letter D, 1/5. Our example number 4, Lamp Depot has two stores. The graph shows sales data from two stores for an 8-week period. Okay, so our straight line here is store 1, okay, while our dashed line here is store 2. So our vertical scaling here on the y-axis, we have the number of sales, okay, number of sales with 20 interval, while here we have the number of the week from week 1 to week 8. Question number 1. About how many more sales were there at store 2 than at store 1 in week 6? Okay, so we only have to focus here on 6. So store 1 has 340, while store 2 has 390. So this is between 380 and 400. So giving us a solution, 390 minus 340 gives us 50. So our answer is letter B, 50. Last question, number 2. During which week did store 1 experience the greatest increase in sales from the week before? Okay, so we will just focus here on the line, not the dashed line, on the store number 1. So we charging upon the slope, we have here 260, 280. If you are not so sure in judging slopes, you can manually check the um, numbers and do some operational difference. 260 going 280, that is a 20 an increase. 280 to 310, so this is a 30 increase. Okay, from here we're talking only about increase. 280 to 320, that is a 40 increase. Then we have here 20 to 40, 20 increase, 10 increase, and here we have no increase. So our greatest increase here is 4 going 5. So it is encountered on week 5. Our answer is letter Z. So I believe you are done with our lesson for this video. So, congratulations! You have now completed this lesson. You can be able to understand better our next lesson, circle graphs. Life keeps moving forward. As line graphs never go backward, may our focus will be always on positivity to whatever challenges we may encounter along the road that gives us to keep moving forward. Before I end this video, let me share with you a verse from the Bible. John 3 verse 30 says, He must increase, but I must decrease. May despite our progress in life and our past in choosing God, drawing near and ever deeper and until now, our faith, hope, and love to God may increase and decrease, but we hope it just never ends until He comes. Let us get to know Him deeper, and the more we get to know Him, the more humble we become, and the more He is glorified. Once again, have a nice day everyone, and see you in the next video.